I hope you get the feeling that in oil removal, it's not the oil that's the issue, it's the solids. It's the solids that creates the problems for coalescers to function, especially in the higher efficiency end. Gaps have to be closer, meshes have to be tighter, and with that, it's the solids that are the key issue. And when we designed our coalescer plate pack way back, we took a look at industry and asked questions, and our clients told us that it was solids that was creating the largest issue for them. So as we designed our coalescer plate pack, we looked at solids as a key in design of a coalescer. If we can process oils, if we can process solids, we're going to create a coalescer that has long runs, high efficiency. And one thing that we at Mercer have done is we've kind of created a formula, and the formula is something that we look at. It's not a technical formula, but it holds true. The formula is oil plus solids plus time equals sludge. So it's true in the industry. Anytime you have oil and it's in the presence of solids, and over time, it always is the same thing. It always creates sludge. And that's what we have done at Mercer, is to take a look and to see how can we deal with that. I brought along a sample coalescer plate pack, and this coalescer we can walk through and show some of the design. What we want to do in a coalescer is we want the flow to enter this entry area evenly. So the first thing that we do before we even touch the coalescers, we deal with the front end of this separator unit. We do a good job on a complete pre-designed flow distribution system. So as we enter the separator, the first thing our separator hits is an inlet chamber. The inlet chamber takes the flow, slows it down, gets rid of the eddy currents and the velocity and energy in the flow. Then we hit a baffle plate system in which we spread the flow from side to side to the coalescer and from top to bottom. It goes through that baffle plate and hits a secondary plate. The secondary plate further spreads out the flow. If we don't do that, what we end up with is flow hitting the center area of the coalescer and less flow in this area, and the coalescer won't perform. Much of our competition spends little time on flow distribution, and they end up using the coalescer plate pack, eating into that to use as flow distribution. If there is no flow distribution, the flow will hit, the velocity will be uneven, and through the pack, it will self-regulate itself, and you might eat in 30, 40, 50% of the pack before you have good flow distribution. And now your efficiency of your coalescer drops. We also, probably one of the last ones out there to have outlet flow distribution. And the reason being is the outlet of a separator is usually down towards the bottom at the cleanest spot. So if you do a good job with flow distribution up front, instead of having that flow coned down to the bottom, we want equalized flow. So a flow distribution at the back of the coalescer helps to create a plug flow through the entire coalescer. So once we have established good flow velocity front and back and side to side on the coalescer, we have some items that we feel make the coalescer have longer runs with solids. One of them is a flat plate design. Remember we said earlier, this is a flat plate design. It's the time-honored flat plate design. This design, as you can see, has no nooks and crannies on it for solids to lodge. We put our plate pack at a steep 55-degree angle. And at this 55-degree angle, we can overcome the friction losses of solids on a plate, and we can have those solids move. If we're processing solids down and out of a pack, then we're in good shape. The other thing we do differently than most of our competition is we have a herringbone design. In this case, with one pack width, a small unit, it's a V. On a larger unit, you'll be able to see that it's a herringbone where the plate system is set up this way. By doing that and having short plate widths, we can take the rise and the run of the plate and keep that ratio much tighter. That way, instead of solids particles starting here and having to go all the way down the coalescer system down and out, it only has to go this short distance to be processed out of the plate pack. That's very important because we can get our plate gaps tighter and tighter and tighter with less fouling. And this kind of setup especially becomes important with the larger and larger units. If you can imagine a 600, 700, 800 GPM unit may have a width of 7, 8 feet. Solids may travel 6 or 7 feet to process out of the pack. With a multi-pack design with the herringbone short plate widths, they never have to travel more than 24 inches to go down and out of the pack to be processed out of it. Another thing that we do differently from many packs is a cross-flow design. So instead of our flow, if I take a plate, coalescer plate pack, instead of our flow coming this way, upflow and out, or a configuration this way, if you can see it, where the flow comes in and downflow, you have problems. The upflow creates problems for solids dropping back and fouling. If you have a downflow design where your flow is coming in, down, and out, solids do process, but the oils fight against the flow, creating issues, especially when you have very tight plate gaps. When you get in that tight plate gap position, you get fouling due to an upflow or a downflow design. On the better designs, like on the Mercer design, you'll see that it's a cross flow. Here, you have flow coming in this direction. Solids drop in generally the same direction as the flow. Oils come up and out in generally the same direction, and therefore you have a cross-flow design. Cross-flow design is good because you can, at that point, tighten the plate gaps up with less fouling. Another very interesting feature that we have, it's unique. You won't be able to see it on this model here, but you'd be able to see it as we show it, is that we have a chimney zone feature. In our chimney zone, what we do is we have a solids that will fall out into this area and hit a 4-inch wide chimney. This chimney is baffled from front to back of the coalescer, and what that does is it creates a zero velocity zone. So within a coalescer plate pack system, say a 500 GPM unit, you may have 4 or 5 chimneys, and the chimneys are dedicated for solids. And then the next pack next to it will have 2 dedicated chimneys for oils. So you'll have a dedicated oil chimney, a dedicated solids chimney, a dedicated oil chimney, and so forth. So here we can take solids, move it out quickly into the coalescer plate pack chimney zone area, and at that point, once it's in this quiet zone, it can take all the time it needs to settle out. And in this case, it won't be carried out. The oils won't be carried out once they hit the chimney zone. Now, by having dedicated chimney zones, what we do is we keep the oils and solids apart. Remember, oil plus solids plus time equals sludge. So if we can keep them apart from each other and commingling and creating the sludge, we can go longer runs. So with the chimney zone, with the cross-flow design, with the flat plate design, we increase the time between cleaning. Now, with the flat plate design, real quickly, as it is time to clean, you're able to get to a flat plate system and clean all the way through, from front to back. You're able to come to this part of the coalescer and clean this way, flat plate. So you can go all the way into the chimney and flush the whole thing out. So every angle of the coalescer, whether it be front, top, or side, is able to be cleaned. And the last feature I wanted to talk about was one of our unique features, the adjustable plate coalescer. And the multi-pack is a pack in which you can field adjust the plate gap. It's unique in the industry for that. And what I mean by that is you can actually pull plates or add plates in the field to meet a certain field condition, whether your flow rate's increasing and you have to deal with that, or the solids loading's increasing, or down the road when the efficiency requirements increase, you can deal with that by adding plates. Typically we ship a plate pack with every other plate in place. By doing that, we give the versatility of upgrading if there's the need, or you can pull plates out if they're so high solids that the problem is in maintenance. So, for instance, we can pull out, say, every other plate on our coalescer plate pack system in the field. So you can see here that if we do that, we're able to change the plate gap in the field. So if this were every plate in place and we pulled it out, now instead of, say, a 1/4 inch gap or 1/2 inch gap, we could double that to 1 inch. We can go from any 5/16 inch right angle gap all the way up. So that translates into 1/2 inch gap increments vertically. So as you can see here, much more gap in this area than this area. This will foul less. This is going to be more efficient. So by pulling every other plate system out here, we've changed the fouling characteristics of the plate pack. Now, had we needed more efficiency in the field, we could have added plates, say, throughout. And by adding plates, we're going to double up the surface area and squeeze out more efficiency for the effluent requirements. The other thing that we've seen done in the field, you have to put a little time and energy to do this, but if you keep track of the fouling in a plate pack system, you can actually find areas where the more solids are going to be. For instance, typically near the very bottom of the pack or up near a sludge layer on the top. If you strategically pull plate gaps, you can keep a high efficiency in one area, while in an area where there may be more fouling, you can pull plates just in that area. And by doing that, you kind of get the best of both worlds. The other thing we've done, kind of unique, is we've also built plate pack systems where as the plates go through, we actually can increase the number of plates as you go through the plate pack. So the front of the pack is designed to pull out the heavier solids, and as you drift through the pack with your wastewater, there are more plates in place back here. And by doing that, we can have a very high efficiency and a very low maintenance system that will be good for years to come in the effluent requirement that industry may find.